So we're diving deep into mean absolute error, MAE. Maybe you've seen it pop up and wondered what it's all about, this whole average error thing.
Yeah, it's more common than you might think. Predictions are everywhere these days, from, like weather forecasts to when your takeout's going to arrive. MAE helps us figure out how accurate those predictions really are.
Exactly. And I have to say, I remember the first time I saw the formula, and it seemed a little intimidating, to be honest.
Oh, absolutely.
But then you break it down, it's like, oh, this is actually pretty intuitive.
Yeah, the Wikipedia article actually does a good job of laying it out. It's basically about taking the absolute differences between what was predicted and what actually happened and then just averaging them out.
Yeah, it's like, imagine you're trying to predict, say, how many people are going to show up at let's say, a local park on a sunny Saturday.
Mm.
MAE is all about, like, how far off, on average, was your prediction from how many people actually showed up?
That's a great example. And the smaller that MAE is, the closer those predictions are to, what actually played out in the real world. It gives you a sense of how well your prediction model is actually doing.
Makes sense. So a small MAE for something like, I don't know, predicting daily temperatures would mean those forecasts are pretty reliable.
Hmm.
But when you think about things like stock prices, I imagine even a small error there could be a pretty big deal, right?
Oh, yeah, you're hitting on a really crucial point there, and that's the importance of context. What we consider a good MAE totally depends on what you're trying to predict in the first place. I mean, different fields have very different tolerances for error.
So predicting, let's say, who's going to win, I don't know, a hot dog eating contest would have a much more forgiving MAE than something like predicting, where's that Mars rover going to land or
Yes,
drop.
exactly. And, that actually brings us to a really important concept when we're talking about MAE, which is that it's what we call scale dependent.
Okay, scale dependent. The Wikipedia article mentioned that, but I have to admit I wasn't totally clear on what that means in practice.
So in the simplest terms, it means you can't directly compare MAE values if the things you're measuring are completely different scales. It's kind of like, it's the old saying, you can't compare apples and oranges, or
Yeah.
maybe apples and watermelons to make it more accurate to the scale difference.
Okay, I'm intrigued. Give me one of those aha moments.
Okay, think about it like this. Imagine you're trying to compare the MAE of predicting a company's annual revenue, which might be, in the millions, maybe billions of dollars,
Okay, yeah, huge numbers.
with the MAE of predicting how many cups of coffee your local cafe sells each day, which is probably only going to be, in the hundreds.
Ah, okay, I see where you're going with this.
All right.
Even what seems like a small MAE for that company's revenue could actually represent a much bigger difference in real-world terms.
Exactly. The scales are so different that you're not really comparing the same thing. So it's not just about the MAE number itself, but understanding what that number means within the context of what's being measured.
That makes this whole idea of scale dependency so much clearer. You need the right measuring stick for the job. You wouldn't use a teaspoon to try to measure a swimming pool.
Now you've got it. And that's actually where things get even more interesting because different scales often need different error measures altogether.
So it's not just MAE, like going solo.
Sure.
There's a whole team of error measures.
Mhm.
The Wikipedia article did mention a few others. There was RMSE, MAE, MALE. It's like this whole lineup of statistical all-stars. Tell me more about these other players.
Yeah. Well, it's think of it less like a competition and more like each one has its own strengths and weaknesses, making it better suited for certain situations. Let's start with RMSE, or root mean squared error, since it's the one you usually hear about alongside MAE.
Okay, RMSE, hit me with the highlights. What makes it stand out?
So RMSE is similar to MAE, but instead of just taking those absolute differences, it actually squares them before averaging them. And as you can imagine, squaring a number, especially a large one, can really amplify it.
So it's like MAE with a magnifying glass.
Exactly. RMSE is much more sensitive to what we call outliers, those really big prediction misses. Think about it this way. Let's say you're trying to predict, I don't know, daily rainfall. And most days your prediction is only off by a couple millimeters. But then there's that one day where you're way off, you predict a light drizzle when it actually pours.
Oh yeah, that one big miss is really going to throw things off.
And that's where RMSE comes in because it amplifies the big errors. It would flag that huge downpour miss way more prominently than MAE would.
So if you're talking about situations where even one big mistake is a really big deal, RMSE is the error measure you want on your team.
Exactly. Now, the others you mentioned, MAEs and MAIL, those are more like specialized players. They're brought in for specific cases. We don't need to get bogged down in the details right now, but it's good to know that, they exist for those more niche situations.
Okay, that makes sense. So we've got our all-rounder MAE and our outlier-sensitive RMSE. But, the Wikipedia article also mentioned this thing called an optimality property of
Yeah.
MAE. It almost sounds like noble.
Yeah. It's actually pretty important. It all comes down to this. MAE has a really special relationship with the median.
Median, right. Like if you line up all the numbers, it's the one in the middle. Like when you talk about the median house price in a neighborhood.
You got it. And here's what's interesting. When you're using MAE to evaluate your predictions, it's almost like you're being guided toward finding that median value.
So if I'm trying to figure out, I don't know, like the median income in a certain area, using MAE would help me zero in on that, like that sweet spot, that most typical income level.
Exactly. And this property makes MAE really valuable for any field where understanding that central tendency, that median, is super important.
So it's like MAE has a built-in compass, always pointing toward that middle ground.
That's a great way to put it. And it's this optimality property that really makes it unique and so valuable.
This is starting to make a lot more sense now. It's like MAE's more than just this formula. It's a different way of thinking about this whole idea of accuracy and how we analyze data.
Exactly. And that deeper understanding is what we want you to take away from this. Now, before we jump into some other interesting stuff about MAE, what's really resonating with you so far?
Honestly, this idea that MAE has this optimality property
Yeah.
related to the median, that's a game changer for me.
Yeah, it's a pretty powerful concept, and it really shows how MAE can be used not just to measure errors, but to actually guide us towards finding the most typical value in a set of data.
It's like finding like the hidden signal in all the noise. I'm hooked. You mentioned some other interesting stuff about MAE. Tell me more.
Well, the Wikipedia article, it mentions this idea of breaking down error into two parts: quantity disagreement and allocation disagreement. And this adds a whole other layer to how we think about accuracy.
Quantity disagreement and allocation disagreement. Those sound like really interesting. It's like two sides of the same accuracy coin.
That's a great way to put it. Imagine, let's go back to predicting how many people show up at that park on a Saturday. But this time, let's say you're predicting for each hour of the day.
Okay, so like I've got my prediction for how many people will be there at 10 a.m., 11 a.m., noon, and so on.
Exactly. Now, quantity disagreement is about the overall picture. So how far off was your total prediction for the whole day from how many people actually came to the park throughout the entire day?
Okay, so if I predicted like 500 people would come to the park all day, but the real total was 600, then that's a quantity disagreement of 100.
Exactly, you've got it. Now, allocation disagreement, that's about whether you're putting those predictions in the right places. So let's say your overall prediction of 500 people for the day was actually spot on.
Okay.
But maybe you underestimated how many people would be there in the morning and overestimated for the afternoon?
Okay, so even though my total prediction for the day was accurate, my hourly predictions were kind of all over the place. That's allocation disagreement.
Exactly. It's about whether you're consistently over or underestimating for specific time periods, even if your total for the whole day is pretty close.
Wow, that is a really important difference. I mean, if you're thinking about something like, I don't know, planning activities or staffing, knowing where those peaks and valleys are is really important.
Absolutely. It helps you fine-tune things, like maybe you discover a pattern you hadn't noticed before, like maybe there's always a dip in attendance when it gets really hot in the afternoon, and you can use that information to plan accordingly.
Yeah, like maybe schedule a concert for the evening when it's cooled down a bit.
Exactly. So you see, MAE, it's not just about one number. It's like a starting point for a much deeper understanding.
It's like you're having a conversation with your data. Instead of just a yes or no answer, you're getting all the details.
I like that. And that brings us back to why understanding MAE, like all the pieces of it, is so important.
It's about going beyond just how far off and really understanding the why behind it. It's giving me a whole new appreciation for this, like the whole world of data analysis.
And the more comfortable you are with these ideas, the more you'll be able to really understand the data around you.
Speaking of which, we talked about how MAE is like uniquely good at finding that median value in a data set, right? That optimality property really stuck with me.
Yeah.
Can we dig into that a little bit more?
Absolutely. It's really important, and it often gets overlooked. Remember we talked about the median being that middle value, like when you see the median house price?
Yes. That example really made it click for me. It's
Yeah.
like finding the most typical value.
Exactly. And the cool thing is when you're using MAE, it's like you're being guided toward that median value. MAE just likes getting closer to that middle ground, that most typical value.
So if I'm trying to predict, say, the median income for a certain city, using MAE would help me get to that sweet spot, the most common income level.
You got it. And that's what makes MAE so powerful, especially in those areas where understanding that central tendency, that median, is really important.
It's like MAE has its own built-in compass, always pointing us to that most typical value. That's a cool tool to have.
It really is. It shows how MAE isn't just about measuring error. It's a way to understand data on a deeper level.
I'm really starting to see that. We were talking about how there are other error measures out there, each with its own strengths. We touched on RMSE and how it really pays attention to those big outliers.
Hmm.
But I'm curious, are there times when you'd actually choose to use MAE, even if you know there are outliers?
That's a great question. It really shows how important it is to use the right error measure for the job. There are definitely situations where MAE might be better even when you've got those outliers.
Really? Like what? So it's like those outliers, sometimes they're like a big warning sign, but other times they're just part of the natural variation, right?
Yeah, exactly. Like, imagine you're looking at data where it's normal to have a few outliers here and there.
Like how long people spend at the library. Some people are just running in for a quick minute, and other people are there for hours.
Exactly. If you use RMSE in that case, it might make your model, way too sensitive to those people who are camped out all day. And then it wouldn't really reflect how accurate it is for the average person who's just there for a normal amount of time.
So if you don't want those outliers to like steal the show,
Yeah.
MAE might be the way to go.
Exactly. It gives you a better picture of like the typical error without overreacting to those extremes. It's about picking the error measure that really makes sense for what you're trying to understand.
This is making so much more sense now. It's like we've got all these different tools, and knowing which one to use is just as important as knowing how to use them, you know?
Absolutely. It's about really understanding your data and what these measures mean and using them to, unlock what your data is trying to tell you.
I have to say, I came into this whole deep dive thing thinking, okay, MAE, that's just another one of the statistical terms. But now I see it's a lot more than that. It's like a whole different way to think about accuracy and data.
I'm glad to hear that. That's what we were hoping for. MAE is so much more than just the formula. It's a way to understand data and predictions better.
It's like going from a blurry picture to one that's, crystal clear.
Yeah.
And that makes me feel much more confident about working with data and understanding predictions.
That's great. That's the goal. That confidence will help you ask the right questions, find hidden patterns in data, and make better decisions. And in this day and age, there's no shortage of data to work with.
Okay, so as we're wrapping up this deep dive on mean absolute error, what's the main thing you want our listeners to remember?
This MAE isn't just for, math whizzes. It's a tool for everyone. So the next time you see a prediction or a forecast or really any kind of data analysis, think about the MAE. Think about the context, the scale of what's being measured, and whether those outliers are important or not. Don't just take the numbers at face value. Think critically, ask questions, and let MAE be your guide to understanding the information all around you.
It's about, like, being a smarter, savvier consumer of data. Love it. MAE, it's not just an error measure, it's practically a superpower. Thanks for joining me on this deep dive. Until next time, stay curious and may all your data be insightful.